Hello! Today we will continue comparing fractional numbers, but we will look at a slightly unusual task, which is very often offered to you. The assignment looks like this. I have some fractional numbers. 1, 2, 4/5, and then 2/3, and a number 6/7. And I need to put these fractional numbers in ascending order. That is, I need to write them down in such a way that the smallest number, in this case the smallest fraction, comes first and the largest fraction comes last. That is, I'm going to write it down briefly in ascending order. So what do we do in this case? Clearly, we need to compare fractions, but how do we compare them? Especially here, I have 4 fractional numbers. The thing is, we're not going to compare these fractions in pairs. These fractional numbers in pairs. Although, in principle, this is also an algorithm for solving this problem. I'm going to suggest to compare all the numbers at once. And what do you need to do for this? The thing is that these are not mixed numbers, they are just fractional numbers. And then in order to compare fractional numbers, we need to bring them to a common denominator. And very often that's where you make mistakes. What do? That's okay, we find common multiples, least common multiples for the numbers 2, 3, 5, and 7. I've written them in ascending order, although they can be written in any order. So what do? We can just count with you, but that would be a very long way to go. So what do I suggest you do? I want you to visualize that 2 is just 2 times 1, and 3 is just 3 times 1. 5 is just 5 times 1, and 7 is just 7 times 1. Why did I write that out? I wanted to see if they have a common multiplier. Yes, there is that one, but the thing is, when we find the least common multiple, we don't take the one into account. And then to find the least common multiple, I'm just going to multiply all of these numbers. So that's how I'm going to write 2 times 3 times 5 times 7. By the way, when we discussed the algorithm of reduction to the common denominator, I offered you another way of reduction to the common denominator, and then I put each denominator into multipliers and took the maximum degrees of these multipliers. But here I do not repeat these multipliers, so I have the right to multiply. And now we're multiplying. So 2 times 3 is 6. 6 times 5 is 30. 30 times 7 would be 200, and now I just need to bring it to the common denominator. So I divide 250 by 2, that's 100. 5, 210 I divide by 5, that's 42. 210 I divide by 3, that's 70. And 210 I divide by 7 is 30. And now we bring everything to the common denominator, even though we have some, well, big extra sets, that is, numbers, some big ugly ones. It's okay, so multiplying by 1 again is 105. And 105 times 2 is 210. Then 42 times 4 is 168. And the denominator, of course, is 210. Similarly, 140 210ths. That's 2/3 when we bring it to the denominator, and the next last fraction is 180 210ths. Now look at the fractional numbers that we've got. I can see that the smallest one is the smallest. Once again, coming back to our task, we need to put them in ascending order, i.e. from the smallest to the largest. I can clearly understand which fractional number is the smallest here. Of course it is 105. 210ths, then I have a fractional number, 140. 210ths. Next 168, 210 of 180. 210ths. Of course, you'll say it's very easy, but the thing is that in the answer there, you need to write down not the common denominator fractional numbers, but the original numbers. So when I put them in ascending order, I'll now sign what the numbers were. So it was 1, 2, and 140, 210 was 2/3. And the next 168 was 4/5. And 180 210ths is a fraction of 6/7. And we've arrived at the final answer. We can put the same numbers less and less. That is, 1 second is less than 2/3, and 2/3 in turn is less than 4/5, and 4/5 is less than 6/7. All we have completed this task and recorded in ascending order. In a similar way, are solved tasks in which you need to write fractions in descending order, that is, from the largest to the smallest. The only thing is that to achieve this, you, again, need to bring to a common denominator. In our next lesson, we're going to look at the representation of fractional numbers on a coordinate line. That's all for today. Goodbye and see you again.